Hello, everyone. This is the recording for the Perceptron algorithm. Now, we talked a lot about the theory and stuff like that in class, going through the slides. So please go through those slides. Make sure you understand what it is we're doing here, making a linear classifier, because I'm just showing the Excel part in this video. You can also find the other profs' recorded lectures under the supplementary materials. So in this video, we're just doing the perceptron algorithm. We have here a series of points that we want to use to train our classifier, right? This is our training data. And so we have the x coordinates of each of those points, and then we have the label. The y coordinate is always just 1 or -1 because it's a binary variable that we're trying to predict. And so what we do then is we start with a line, and we start with a line that's not really a line, which is just 0, 0, 0, right? So 0, x1 plus 0, x2 plus 0. This is the equation of, well, it's not even really a line, like I said, but we're just starting here. That's our initialization, and we're going to get a line as soon as we start to update things. One thing that I should mention is in this formula, so in this Excel document that you get from the tutorial, there is a little mistake here in this heading. This heading should be y times all that stuff, which is what we're going to be doing here. So that's the first thing we're going to do is we're going to set this equal to, we're going to do the brackets first, right? So we're doing θ1 times x1. So this is θ1 times x1 plus θ2 times x2 plus θ0. None of these are static. All of these are relative. They're all going to move. That's the part inside the brackets, and then we need to multiply by y, which is here. Right? And now if you have read the slides, you know that what we've got here is essentially going to tell us whether or not the prediction that we make using this line is correct or incorrect. A positive number is correct. A negative number or 0 is considered incorrect. So we're getting 0 here, which is always what's going to happen in the first step. But that's okay. We're going to copy and paste this all the way down. And then we need to start updating our thetas. So the formula for updating your thetas goes like this. If the prediction was greater than 0, in other words, if it was correct, then we don't update. The new θ1 is just the same as the old θ1. Period. Nothing changes. But if that's not the case, so if our prediction was incorrect, we are going to update our θ1. How do we update our θ1? We take the old θ1 and we add y times x1. And then for θ2, it's very similar. If our prediction was correct, so this value is going to be greater than 0 whenever our prediction is correct, then we don't need to update θ2, and the θ2 is just the same as it was. Otherwise, we take the old θ2 and we add y times x2. And then the θ0 is again similar. If the prediction was correct, if this number is greater than 0, then we take the old θ0 and we don't change it. Otherwise, we take the old θ0 and we add y. So this is our new equation for our line. So the equation goes 2x1 plus 4x2 plus 1 equals 0. That's the equation of the line. And so then if we apply this stuff inside the brackets, right? θ1 times x1 plus θ2 times x2 plus θ0 to a new x1 and x2. If the result is positive, then we're going to predict y as positive. If the result's negative, we're going to predict y as negative. That's how that works, right? And then we multiply by y to check if we were correct. In this case, we were correct. So because this is positive, this means that our classifier was correct for this point. And so if we copy and paste this down, we should see that they don't change. And again, they don't change. And again, they don't change. They're not going to change until we get a negative or a 0, right? Because anytime we're getting a positive, that means our prediction was correct. So we don't need to change our classifier. But here, this should change, right? The 2, 4, 1 should now change. And it does. Now it's 4, 1, 0. And now this is positive. So again, we can paste it down and it shouldn't change. 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 Okay, so we've gone through all the points and our classifier has been correct for a while, but what we need to do to be sure it's correct is we need to run through all the points again, because having a classifier that's correct for these points, right, doesn't mean it's correct for the original points. It might be incorrect up here now. So we're going to take this, we're just going to copy and paste literally all of this down. But now we see what happened. These were all positive. In other words, all of these were correctly classified. The classifier never needed to change. So we've gone through an entire cycle of all the training data without changing our classifier. That means our classifier is able to correctly divide this training set into yeses and nos, plus ones and minus ones, essentially. Right? So we have linearly separated the points. And so our classifier is going to be 4x1 plus 1 x2 plus 0 equals 0. That's the equation of the line. Right? And those should be subscripts here with the 1 and the 2, but you know, you get it, right? So that's the equation of the line, and anytime you plug in an x1 and x2, if the result you get is greater than 0, you're going to predict that the y is a positive one. And anytime the result you get is less than 0, you're going to predict the y is a negative one. So let's just take an example point. Let's say the point was 3, negative 1. Right? That's our point. We're trying to classify what is the y value likely to be here. So what we're going to do is we're going to do 4 times the x1, which is 3, plus 1 times the x2, which is negative 1, plus 0. Right? And we're getting 11. This is greater than 0. So we're going to say that we predict y equals 1. Right? We're going to predict a positive 1, not a negative 1. Right? You can do formulas for this too, right? You can do, you know, if you had a point and you could write the, for instance, you had like the x1 and x2, and we had our 4, 1, 0, right? We could write this is going to be this times this plus this times that plus this, right? That'll give us our 11, right? And then if we want to say, turn that into a 1 or a negative 1, we can just do if this is greater than 0, then we're going to predict a 1. Otherwise, we're going to predict a negative 1. Right? And this is going to be perfect as long as the point does not lie directly on the line. Because if the point lies directly on the line, then you actually don't know which way to predict. So we're going to talk a little bit more about that next time, I think. But for now, this is good enough, right? This will work for any point that's not directly on the line. The other thing I showed in class was just the conditional formatting stuff. So for the conditional formatting, if we go into conditional formatting here, we want to add in a rule. If this is greater than 0, we want it to be green, right? So, and what else? If it's less than 0, we want it to be red. And also, if it's equal to 0, we want it to be red. So we can just do that this way. We can just have a greater than, an equal to, and a less than. Right? So now all the less thans are red. All the greater thans are green, and all the equal to zeros are also red because they're also considered incorrect. Right? So now it's just highlighting the points where we need to change our classifier. Right? Obviously at step 1, we always change, but then we only needed to change one more time. Right? We only misclassified this one point, changed it, and then after that change, everything was good the rest of the way. Right? You can do more complicated stuff with the conditional class, the conditional formatting here, right? You can add in more rules, and you can say, let's say I wanted to do, instead of doing the less than 0 and the equal 0 as two separate rules, I could do a less than or equal to 0 as a rule, and I could set a format, and the format I set could be that I want it to be bold, and I want it to be, you know, this red here maybe. Right, and so if I did that, I click OK. Okay. Now if I copy that around, I can see I'm getting different red ones. Right? You can just change it, match whatever you want. Things are getting a little bit mixed up, I think, because I still have the old rules. I didn't actually remove the old rules, so now I have two conflicting rules here. But anyway, right? It's just showing you the different things you can do with conditional formatting. All right, and we're going to use conditional formatting a fair amount in this in the next little while, just to help us more easily notice when things are updating, when things are changing. Right? What's been properly classified, what's been improperly classified, that sort of thing. Okay, so that's it. That's the video. So we're gonna work on more classifiers this week in class.